Welcome back. So if you were with us for season 1, we covered a lot of ground, all the historical battles, the big ideas.
He really did. We built that whole foundation, right? From Turing's first thought experiments all the way through symbolic systems.
And expert systems. But we also, and this is the key thing, we also saw where it all sort of stopped, where it hit a very hard limit.
Exactly. We saw that early AI ran into what you could call a complexity ceiling. I mean, with symbolic AI, engineers had to sit down and write every single rule by hand.
A rule for every possible situation.
For everything. And, that works fine in a closed, predictable world, like a chess game.
Sure.
But the real world, it's messy. It's unpredictable. That kind of rigid, handcrafted logic it falls apart.
It's like the difference between writing a checklist for what a cat is. Must have whiskers, must have pointy ears, and then actually seeing one you've never seen before, half hidden under a bed.
The rules just fail instantly. And that failure point, that brittleness, is really the crisis that gave birth to machine learning.
Okay, so that led to the big question.
The inevitable question. What if the machine didn't need us to write the rules at all? What if it could figure out the patterns on its own?
And that right there is the huge shift we're exploring this season. Instead of a programmer teaching an algorithm, the algorithm teaches itself by looking at data.
Mm-hmm.
So you can think of this season as a kind of guided map through that whole landscape. We want to get past just the definitions and into the real ideas.
And to start, we're going to look at that first conceptual jump, how researchers went from these rigid true-false logic systems to something more flexible, something based on weights and probabilities.
A mathematical shift.
It's a huge shift. That move away from fixed logic is where this modern story really begins.
And from there, we'll get into how the learning actually happens, which it seems to break down into 3 main approaches.
That's right.
The first one is supervised learning. This seems to be the most common one. The algorithm learns from examples that are already labeled.
Yeah, it has a teacher. The data is constantly telling it, yes, that's correct. This is a picture of a stop sign. Or, no, that's not.
And then there's the opposite, which sounds a lot harder. Unsupervised learning.
It is. Here, there's no teacher, no labels. The algorithm just gets a massive amount of data, and its job is to find the hidden structure, to find the patterns all by itself.
Like pattern archaeology or something.
That's a great way to put it. It's what powers things like recommendation engines.
Okay, and the last one, this one sounds the most interesting, is reinforcement learning.
This one is all about interaction. The system learns by doing things, by trial and error. It gets a reward for a good move and a penalty for a bad one.
So it's how a machine learns a complex strategy, like in a game.
Exactly. How to master something with no obvious rule book.
And once we get those big ideas down,
then we can get into the toolkit, the classical algorithms that are still the workhorses of the industry, and maybe the most important part, the engineering side. Right.
How do we make sure these models actually work in the real world on data they've never seen before?
Right, that idea of generalization. That's where it all comes together. So our goal for you this season is pretty simple. By the end, you should feel like you genuinely get what machine learning is. Not just what it is, but why it matters, how it works, and how it connects to all the AI you're hearing about and using every day.
Yeah, season 2 is really the story of how AI got past its early limits. It's how it became this adaptive thing that can learn and evolve. If you understand that shift from writing rules to discovering patterns, you understand the revolution that's shaping everything right now.
Thanks for listening to the Adapticx Podcast. If you have any questions, feel free to reach out to us.